In this video, we're going to talk about trapezoidal rule. And before we do that, let's review about trapezoid. How do you find the area of a trapezoid? Well, the area of a trapezoid is going to be 1 over 2 times the height times the quantity base 1 plus base 2, which is the same thing as h over 2 times the quantity base 1 plus base 2. Remember how we estimated the integral of f of x from a to b using RAM, rectangular approximation method? We drew our rectangles and we add up the area of rectangles to estimate the true value of the integral of f of x from a to b. Now, of course, we had LRAM, RRAM, and MRAM. Now, instead of rectangles, we're going to use trapezoids to estimate the integral of f of x from a to b. So we need to add up the area of trapezoids to estimate the integral of f of x from a to b. Remember the delta x was b minus a over n, where n represented the number of rectangles. Now, n represents the number of trapezoids that we're going to use. And here, the delta x represents the h, the height of the trapezoid. So h will equal to b minus a over n. Remember, the area of a trapezoid is h over 2 times the quantity b1 plus b2. So here, this is the h of this trapezoid. And what is the base? Base is going to be f of x of 0. And the base over here will be f of x1. So the area of a first trapezoid is going to be h over 2 times f of x of 0 plus f of x1. This is the area of a first trapezoid. Now, how do you find the area of a second trapezoid? That's going to be h over 2 times, what is base 1 now? It's going to be f of x1 plus f of x2. And how do you find the area of a third trapezoid? That's going to be h over 2 times the quantity f of x2 plus f of x3. Here the base 1 becomes f of x2, base 2 is f of x3. Now, what is the area of the fourth trapezoid? That's going to be h over 2 times the quantity f of x3 plus f of x4. Now notice we have a common factor here, h over 2. So let's take out h over 2. And you're going to get f of x of 0 plus f of x1 plus f of x1 plus f of x2 plus f of x2 plus f of x3 plus f of x3 plus, and finally, f of x4. Now you could combine these two, and these two. So it looks like you combine the middle one except for the first and the last. So you get h over 2, quantity f of x of 0 plus 2 times f of x1 plus 2 times f of x2 plus 2 times f of x3 plus f of x4. And this is the approximation of the integral of f of x dx from a to b using 4 trapezoids. So we could say that the integral of f of x from a to b is approximately h over 2 times the quantity f of x of 0 plus 2 times f of x1 plus 2 times f of x2 and all the way up to f of x of n, where n represents the number of trapezoids. So n minus 1 is a previous term. If n is 4, then this one will be x of 3. Notice all middle terms have 2. And we saw the reason why earlier. And also look at h. h is b minus a over n. So when you substitute h with b minus a over n, you get this right here. And this formula looks confusing, but as we do examples, you understand it better. In our textbook, instead of f of x of 0, they use y of 0. And instead of f of x1, they're using y1. So don't get confused with the notation. And also what's interesting is that the trapezoidal rule is same thing as adding the LRAM plus RRAM and then dividing by 2. So you may use this as well. But basically this is the same thing as the trapezoidal rule. So let's take a look at example 1. It says use the trapezoidal rule with n equals 4, which means 4 trapezoid, to estimate the integral of x squared dx from 1 to 2. And compare the estimate with the exact value. This NINT means use a graphing calculator to find the exact value of the integral. So we have y or f of x equals x squared, and we're going from 1 to 2. A is 1, b is 2. So what is our height? Height is going to be b minus a, which is 2 minus 1 over n, which is 4. They're saying that n equals 4. So h is 1 over 4. So height of each trapezoid is 1 over 4. So how can we find these values in the middle? All you got to do is keep adding 1 over 4 to each value. So you end up getting 5 over 4, 6 over 4, 7 over 4, and 8 over 4, which is just 2. So this is x of 0, x of 1, x of 2, x of 3, and x of 4. Now what we're going to do is we're going to substitute. So h is 1 over 4. So 1 over 4 divided by 2 is 1 over 8. And we need to find f of 1 plus 2 times f of 5 over 4 plus 2 times f of 6 over 4 and so forth. Now remember, our f of x or y is equal to x squared. So in order to find f of 1, you got to plug in 1 for x. And if you want to find f of 5 over 4, you got to plug in 5 over 4 instead of x and so forth. So you get something like this. And then when you simplify even further, you get 75 over 32, which is equal to 2.34375. So this is the approximate of the integral using trapezoidal rule. So this is basically what we did. We got 4 trapezoids from 1 to 2, and we got the area of each trapezoid, and we add them up, all the areas, in order to estimate the integral of f of x from 1 to 2. Now our actual value is 7 over 3, which is 2.333333, and our approximation is not that far off from the actual value. Again, if you want to get closer to the actual value, you need to increase the value of n, the number of trapezoids.